morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I want to discuss about failures of a riveted joint. In previous session, we have discussed about riveted joints, and in this session, we will see what are the failures of a riveted joints and how to calculate these failures. So there are many failures are there, like tearing of the plate at an edge. So this is the first type of failure. So in this type of failure, a joint may fail due to tearing of the plate at an edge. So as shown in the figure, so I will show you a figure. So this can be avoided by keeping the margin 1.5 times of D. So where D is the diameter of the rivet pole. So you should avoid this type of failure. So to avoid failure for safe design, always you should take the margin value is equal to 1.5 times of D. See the tearing of the plate at an edge as shown in this figure, when it is subjected to tensile load. This is the rivet wall and rivet shown, the diameter of the rivet, and this is shown margin. The margin is equal to 1.5 times of D. You should maintain to avoid failure. But the margin is, as per definition, the edge, it is the distance from its edge of the plate to its center of the rivet. See here the tearing failure, tearing of the plate occurred at an edge. So that's why to avoid this failure, always take the margin value is 1.5 times of D. This is the standard value recommended by BAS. The second type failure, tearing of the plate across a row of rivets. So not at an edge. So due to tensile stresses in the main plate. So whenever the main plate subjected to tensile load, in case of butt joint, the main plates or cover plates may tear off across a row of rivets, as shown in figure. So in such cases, we consider only one pitch length of the plate. So why? Because every rivet is responsible for that much length of plate only. So I will show you diagram. See, in this diagram, the tearing of the plate across the rows of rivets shown. In this, when it is subjected to tensile load, here, so see, the tearing may occur across these rows, the rows of the rivets. So already you know the distance between the two rivets is called as pitch, and this is diameter of the rivet. So you can calculate the remaining distance P minus D. So mainly the tear will occur across the rivet. So to avoid this type of failure, only we will consider one pitch length of the plate. Next, the resistance offered by the plate against tearing, known as tearing resistance or tearing strength or tearing value of the plate. How do you calculate the tearing strength? We should know. So what is the tearing strength? How much resistance offered by the plate? So here let pitch of the rivets, D diameter of the rivet wall, and T is thickness of the plate, and sigma T permissible tensile stress for the flat material. So already we know that the tearing area for pitch length is P minus D into T, as shown in figure. The pitch length P minus D multiplied with T, it gives area. So area resistance, now T resistance are full required to tear off the plate for pitch length. That is, you can calculate by using this relation. Strength is equal to area multiplied with permissible tensile strength. So finally, you will get P minus D into T into dt. It gives tearing strength or tearing value. Next, third type failure is shearing of the rivets. So in this, the plates which are connected by the rivets exert tensile stress on the rivets. If the rivets are unable to resist the stress, they are sheared off. So as shown in figure, when it is subjected to load. In first case, shearing of a rivet in a lap joint. In second case, shearing of a rivet in a single cover butt joint. Shear off. So like this. So it means the rivets are unable to resist the stress. So the shearing strength we can calculate by using these empirical relations. So let D is the diameter of the rivet wall and shear tau is the permissible shear stress and N is number of rivets per pitch length. So and then calculate this in a single shear area 5 by 4 into D square. So in case of double shear, need to multiply with 2 into 5 by 4 into D square. For boiler making, according to the Indian boiler regulations, take this value 1.875 into 5 by 4 into D square. So finally, you can calculate the shearing resistance are full required to shear off the rivet for pitch length by using this empirical relation. In single shear, so number of plates multiply rivets multiply with the area and shear stress, permissible shear stress. You will get shearing resistance. Next, in double shear, according to Indian boiler regulations, so take this empirical relation 1.875 to 5 by 4 into D square into tau. So when the shearing resistance, so that is PS, is greater than the applied load per pitch length, then this type of failure will occur. Clear? So that's why need to calculate the shearing resistance of the joint. Next failure is crushing of the plate or rivets. So sometimes crushing occurs at the plate edge and sometimes rivets are crushed. So sometimes the rivets do not actually shear up under the tensile stress. So sometimes they crushed. So as shown in figure, due to this the rivet wall becomes an oval shape after crushing. Initially the wall is circular shape. So after crushing it becomes an oval shape. So finally the joint becomes loose. So this type of rivets in such a manner, the failures are also known as the bearing failure. So bearing failure means the area which resists the action is projected area of the wall or rivet on diametral plane. So this type of failure is crushing resistance or crushing strength or bearing value of the rivet. So how to calculate this crushing strength and bearing value of the rivet shown in this slide. So let take D, diameter of the rivet wall, T is the thickness of the plate and The sigma c is the safe permissible crushing stress, n is the number of rivets. So here shown the total crushing area, n into d into t, n is here number of rivets. The crushing resistance are full required to crush the rivet for pitch length is n into d into t into sigma c. So in this, when the crushing resistance Pc is greater than the applied load, this type of failure will occur. Clear? So see, in this diagram, when it is subjected to load, the crushed at rivet area. So initially, the whole shape, the rivet on the shape is circular. After crushing, it becomes oval shape. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.